This is AP Calculus AB Worksheet 2-12 for L'Hopital's rule. As a reminder for L'Hopital's rule, it's whenever you're taking a limit to either a number or to infinity, if you get the indeterminate form, which can look like 0 divided by 0 or some sort of infinity divided by another infinity, then we need to use L'Hopital's rule, which generally states take the derivative of the top, take the derivative of the bottom, and then try plugging it in again. All right, in number 1, it's definitely L'Hopital's rule because I'm going to have e to the power of 0 divided by, or minus 1, which is all 0, and sine of 0, which is also 0. I get the indeterminate form 0 over 0, which is that first form, which means we're going to apply L'Hopital's rule. So I'm not going to take the limit yet. I'm going to rewrite the limit and say it's still the limit as x approaches 0. And when I take the derivative of the top, this is going to be cosine of x. When I take the derivative of the bottom, the derivative of e house is still e house, and the derivative of 1 is 0. So there's the entire derivative of the denominator. Now I'm going to try plugging in 0 once again. When I plug in 0, I'm going to get cosine of 0, all divided by e to the power of 0, and e to the power of 0 is going to be 1. Cosine of 0 is 1. 1 divided by 1 is 1. All right, what about number 2? In number 2, I assume I'm going to get the indeterminate form. I can see, since I'm plugging in pi squared minus pi squared, that's going to be 0. I assume everything up there is going to be 0 as well. Let's make that assumption and continue on. So again, I'm not going to plug in pi yet. I'm still saying as x approaches pi. I'm going to take the derivative of the top. The derivative of cosine is negative sine, and the derivative of sine is a positive cosine. And don't forget your dinner, times 2. The derivative of this 2x is 2. And when I take the derivative of this 1, it's 0, so that 1 goes away. And I'm left with, the numerator is good, okay. The derivative of the denominator, notice that this is just a number, therefore the derivative of a constant goes away, and derivative of x squared is just a 2x. I'm noticing here that I can plug in pi again. Let's see what happens. This is going to be negative sine of pi plus 2 cosine of 2 pi, and that's all going to be divided by 2 pi. All right, so from here, what do I see? I see that we're going to have sine of pi, which is 0, and cosine of 2 pi. Again, 2 pi lives right here. Cosine is just 1, so cosine of 2 pi is 1 times 2, and this all turns into just 2. So I can say this is going to be 2 all over 2 pi, which reduces if I divide the numerator and denominator by 2, I get 1 over pi. 1 over pi is letter option B. All right, what about for number 3? Again, I assume I'm taking L'Hopital's rule. So when I do this, I'm going to still say it's the limit as x approaches infinity, and I'm going to take the derivative of the top, which is going to be negative 12x. Take the derivative of the bottom, that's going to be 3e to the power of x. I don't have to worry about any sort of dinner because the derivative of x is just 1. Let me try plugging in infinity again, and I'm still unfortunately going to get infinity divided by infinity because I still have a place to plug in infinity to the numerator and to the denominator. So I'm going to try taking this again. This is going to be equal to the limit. I still haven't applied the limit as x approaches infinity of negative 12 all over 3e to the power of x. And now notice that I've taken the derivative of the numerator. Again, this 3e to the power of x is going to stay there no matter how many times I take the derivative. Now when I plug in infinity, I can only plug it in into the denominator, which means I have a negative number divided by basically infinity. So this is basically equal to a negative 12 divided by infinity, which is equal to 0. Whenever you have an infinity in the denominator, that's always going to be 0. All right, number 4. Again, we're going to get the indeterminate form. Let's go ahead and take the derivative. So I'm going to say limit as x approaches 0, and derivative of 4x squared is an 8x. The derivative of that denominator is e to the power of 4x. Don't forget your dinner here. Remember that the derivative of 4x is 4, and then I have to do the derivative of negative 4x turns into negative 4, and then the minus 1 turns into a 0. So if I try plugging in 0 again, I'm going to get, this is going to be e to the power of 0. Anything to the power of 0 is 1, so this is going to be 1 times 4, and 4 minus 4 is 0. Plugging in 0 on the top, I still get the indeterminate form, which means I have to take the derivative again. So this is going to be equal to, again, I haven't applied the limit, so I'm just going to rewrite that limit until I actually apply it. This is going to be 8 in the numerator, and e to the power of 4x times 4 times 4. Again, this original first 4 I just copied down, and then this second 4 came from taking a dinner yet again. When I do this, now when I'm plugging in 0, I can only plug in a 0 over here, and this is going to be 8 over e to the power of 0 times 16, and e to the power of 0 is just 1, so this is just 8 over 16, which is 1/2, and the correct answer here is B, 1/2. All right, what about for number 5? For number 5, and I can kind of see where this is going to go, we really have a power struggle between the numerator and denominator. Whenever we're plugging in infinity, it's asking who has the higher power level. And you'll remember from the notes, whenever we're talking about power level, it's whenever we're doing limits to infinity. So limits to infinity, who wins? Remember, exponential is the most powerful, polynomial is okay, logarithmic is really slow, trigonometric is usually bounded by -1 and 1, and a constant is even less powerful. So in this case, I have I was going to say, it is polynomial, it's cubic, right? I have a polynomial divided by an exponential. Exponential is the winner, therefore the bottom wins. Whenever the bottom wins, that means I'm going to have like something like a number divided by infinity, which is going to be 0, but let me show you another way to do this in case you want to do it the long way. If you want to do it the long way, you can say, okay, this is going to be the limit as x approaches infinity of, okay, take the derivative of the top and the bottom. So the derivative of the numerator is 3x squared. The derivative of the denominator is e to the power of 3x, don't forget your dinner, times 3. And I'm noticing that these 3's will both cross cancel, which means I can try to plug in infinity again. You'll notice you can plug in infinity in 2 different spots. Therefore, you still have the indeterminate form, infinity divided by infinity. So let's try taking the derivative again. So I haven't taken the limit yet as x approaches infinity. Let's go ahead and take the derivative again. I get 2x in the numerator and e to the power of 3x, and now dinner is times 3. And I still have a place to plug in infinity, so I need to take the derivative again. So I still haven't applied the limit. I keep rewriting it until I actually apply it as x approaches infinity, and this is going to be 2 in the numerator and e to the power of 3x times 3 times 3. Again, this first 3 was copied down. This second 3 came from the dinner from taking the derivative of e to the power of 3x. And now when I plug in infinity, there's going to be an infinity in the bottom, which means e to the power of infinity is infinity, times 9 is still infinity. I'm basically getting 2 over infinity, which is just 0. As we talked about earlier, you can just apply power levels to do this question much quicker. What about for number 6? All right, so I have a lot of stuff going on here in number 6. Again, when I plug in infinity, I'm going to get infinity over infinity. Let's try to take the derivative of both the top and the bottom. I'm going to get the limit as x approaches infinity and derivative of the top. So whenever you take the derivative of log house, it's always the reciprocal of the inside. So the reciprocal of the inside is 1 over e to the power of 3x plus x. So there's just the derivative of the outer. Now I'm going to multiply that by the derivative of the inner. So I'm multiplying that by the derivative of the inner. The derivative of e to the power of 3x is e to the power of 3x. It's e house, but don't forget your dinner as well. And then the derivative of x is 1. And all of this is going to be over, okay, the derivative of x is just 1. So I might as well not have written anything. I can leave it there just for the notes. So really what I have here, I need to simplify this just a little bit. So this is a simplification step. I'm not retaking the derivative. I'm going to say this is still the limit as x approaches infinity of e to the power of 3x, I guess 3e to the power of 3x because it's times 3 plus 1, all divided by e to the power of 3x plus x. Okay, can I plug in infinity? No, because I still have a power or an x and x to plug in. So maybe I can try the derivative again. So let's take the derivative again. So I still have the limit as x approaches infinity. And when I take the derivative of the numerator, I'm going to get 3e to the power of 3x. And don't forget your dinner, times 3. The derivative of 1 is just a constant, so it's just 0, right? And then for the bottom, we get e to the power of 3x times 3, and then plus 1, which is unfortunate because, again, I still am plugging in infinity to both the numerator and denominator. I'm still getting infinity divided by infinity. Once we get rid of that 1, then magic is going to happen. So I'm going to take the derivative one more time, the limit as x approaches infinity. So taking the derivative of the numerator again is 3e to the 3x times 3 times 3. Again, this 3 was just copied down. This 3 is from the dinner. And then for the denominator, I'm going to have e to the power of 3x times 3 times 3. Again, this 3 and this 3 are the same number, and then this was our dinner. And notice that now we can finally have some things that cancel out. So let's cross off all the things that are in common. Those 2 are the same. These 2 are also the same, which means this is equal to 3. Whew, that was an actual number. Interesting. All right, let's try number 7. And I hope that by now in this video you're seeing, oh, if it doesn't work, you just keep applying it over and over and over and over again until it does work. That's in general how L'Hopital's rule always works. All right, so for this problem, this one looks very much like the definition of the derivative. And again, whenever we have the definition of the derivative, a L'Hopital's rule will always be available. So Yes, you do get the indeterminate form. Let's go ahead and take the derivative. This is going to be the limit as x approaches 2 from both sides of, okay, the derivative of natural log of x plus 3 is 1 over x plus 3. Do I need to multiply by the dinner? I mean, always, but in this case, when I multiply the derivative of x plus 3, it's just 1, so I don't have to worry about it. And then this is just a number, so the derivative of a number, derivative of any constant is 0, so that's just gone. And then I have to worry about the denominator. This is all going to be divided by the derivative of x minus 2 is just 1, which means I'm just going to ignore that and say there's our question. And then when I plug in 2, I'm going to get, here, I'll just leave this over 1 for now. I do like having a solid answer key for other students to refer back to. When I plug in 2, I'm going to get 1 over 2 plus 3 or 1 over 5. So the correct answer here is B, 1/5. All right, what about number 8? In number 8, we're trying to take the derivative. Oh, interesting. So when I do this question, should I be plugging in natural log of x in the place of f of x? That's the first question that I'm really asking myself. And I think the answer here is yes. So I'm going to rewrite this one. So this is just a rewrite. When I rewrite this, this is the limit as x approaches 3 from both sides of, okay, f of x is natural log. So it's natural log of x minus natural log of 3 all over x minus 3. So I haven't done anything aside from swap out the function notation to the natural log notation. And now I can take the derivative of the numerator and denominator. So when I do that in pen, it's going to be the limit as x approaches 3 from both sides. Okay, the derivative of natural log of x is 1 over x. The derivative of natural log of 3 is 0 because it's the derivative of a constant. And this is all going to be divided by the derivative of x minus 3 is 1, which means I can just plug in 3 and I get 1/3 out. So correct answer here is 1/3. Correct answer is A. Very similar to number 7. We got 2 more questions left for the homework. We're almost there. Number 9. This one is really tricky because you have to know power levels. For number 9, I'm noticing that I'm trying to get 0, which means the bottom has to have a higher power level. That's in general what happens when the bottom has a higher power level. You're essentially dividing by infinity. So how do we do that? Well, I'm looking who wins between natural log and a polynomial. Polynomial is more powerful, so this one is indeed going to be equal to 0. I'm just comparing power levels. If you forgot the power levels, again, you should be referring to the notes. Here are the different power levels. Exponential is the most powerful, then polynomial, then logarithmic, then trigonometric, and then constant. So for number 9, I had a polynomial versus a natural logarithm. Natural logarithm lost, therefore the polynomial won. Whenever the bottom wins, the answer is 0. Kind of like your top-bottom rules for your Buzz Lightyear rules, your limits to infinity. Again, these are limits to infinity. Still Buzz Lightyear rules, kind of. Who wins between a natural log function and exponential? Well, exponential wins. Therefore, the answer is going to be the top. Whenever the top wins, that turns into infinity, which is not what we want. So it is not 2. So far, it is yes for 1. What about for part 3? I have polynomial versus exponential. Exponential is always the most powerful. So whenever the powerful is in the bottom, the answer is going to be 0. Therefore, the answer is going to be 1 and 3 only. Correct answer is E. All right. And number 10, we're looking for L'Hopital's rule, applying this where I'm comparing the top versus the bottom, and I want the top to win because I want it to be infinite. So in order for the top to win, we need a winner in the top. All right, let's see what we got. So again, you kind of take the largest power. So here's the top, which means I cross off this plus 2x. And again, for the x squared plus natural log of x, which of those is the most powerful? X squared is the most powerful. When I take look at the top and the bottom, this one is eventually just going to turn into 1, but we want it to be infinite, therefore the correct answer is not A. What about for B? I'm noticing that between the two polynomial functions, the bottom polynomial has a higher degree, therefore the bottom is going to win. Whenever the bottom wins, this one is equal to 0, which means it's not B. Again, we're looking for something that is infinite, right? What about for part C? This is exponential versus polynomial. Remember, exponential is more powerful, therefore the numerator, f of x, is the numerator. This f of x right here is the numerator. And exponential beats a polynomial every single time, therefore this one is indeed equal to infinity, therefore that's the correct answer. But it's still worthwhile to talk about D and E as well. What about D? D, I have an exponential. Again, this is insignificant because exponential beats out the power. Same thing over here. The polynomial is not as powerful as the exponential. So when I compare these two, you'll notice that the e to the power of x cross cancels. This answer is just 3 over 2 or 3 halves or 1.5. So this one is equal to 3 halves. Therefore, it's not going to be D. And what about E? For E, I have 2 different natural logs, so they kind of tie. This one's a little bit tricky, but I think the answer is going to be like something like 3 over 2 as well. I'm not 100% about that. It might be like some weird reciprocal thing. It might be 2/3. I know that's equal to some number though, because the top and the bottom tie, whenever the top and bottom tie, you're usually talking about some sort of horizontal asymptote at a specific value. Therefore, the answer is not going to be E. Whenever you have a tie and power, that's never going to be infinite. Cool. That does conclude this video for worksheet 12 for L'Hopital's rule for AP Calculus AB. Thank you for watching.